going to solve the system using substitution, and then later on we are going to solve the same system, but we are going to use elimination. Okay. So which variable do you want us to solve here? X from the first or second equation? First equation. All right, let's do that. So here, if I'll solve for x, we will have x equal to okay, y plus 25. And then we are going to use this plug into our x, okay, to the second equation. So x, which is equal to y plus 25 plus y equals 71. Combining like terms, y plus y. So y plus y will give us 2y plus 25 equals 71. And then we subtract 25. So what's 71 minus 25? We'll get 46. And then divide 2. We'll get y equals 23. And then we'll go back to this equation, x equals y plus 25. Or you can use equation number 1, equation number 2. You can plug in y equals 23. Either way, you should be able to get the same value for x. But I would rather use this equation that came from equation number 1. So y is equal to 23. I just replace y by 23. 23 plus 25 will give us
71.
Should be 48. Okay. So our equation will now be, our solution is now 48 comma 20. Okay. Now you have to verify your answer. Okay. So verify your answer or check your answer. So x, using the first equation, x is 48 minus y is 23. So is 48 minus 23 equals 25?
Yes.
All right, so this first equation is correct. Let's check the second equation. It says x plus y equals 71. So x is 48 plus 23. Is this really equal to 71? And when you add 48 plus 23, you'll get 71 equals 71. Okay? So there we go. We were able to solve the system using substitution. So next, we are going to start today solving systems using elimination. The idea behind this method is that when you add or subtract two equations, you will be able to eliminate one of the variables, either the x or the y. After that, it should be easy for us to solve the other variable. Now, elimination is best used if both equations are in standard form. Okay, so this is our standard form. So for the first step, okay, when we are solving elimination, when we are solving system using elimination by either adding or subtracting, you have to make sure that you have your equations in standard form. Okay. Now, step is very important. If the equations have opposite terms, such as 4x and negative 4x, okay, if you will add the equation, you'll be able to cancel out your x. Or if you have identical terms, such as negative 4x and negative 4x, you'll be able to eliminate your x if you're going to subtract the two equations. Okay, we'll be able to. So once you add or subtract, one of the variables will be eliminated. Okay, and we will now be able to solve the remaining variable. We'll be able to show these steps in this example number 1. Note that we solved the same system using substitution earlier. Okay, so there's two ways on how to solve this system. Either we eliminate x or we eliminate y. With this example, we are going to eliminate our y. Okay, so you have to decide which variable you want to eliminate. In this case, I would like to eliminate our y. if you look at your y, I have a negative y here and I have a positive y. If I'm going to add these two equations, I know that my negative y and y will cancel out. Okay? So, adding the two equations, I will have x plus x will give us 2x, negative y plus y will be 0. 25 plus 71 is equal to 96. Okay. Next, we are going to solve our x. Solving for x, we divide 2 to both sides, and we will be able to get x equals 48. Once you have the value of one variable, you can use either the first equation or the second equation. I will use the first equation. I will replace the x in my first equation, replace it by 48. So I will have x minus y equals 25 from my first equation. Replacing my x here by 48, I will have 48 minus y equals 25. Solving for y, I will have here, so I'm going to add y to both sides. I'll get 48 equals y plus 25, and then subtract 25 to both sides. What is 48 minus 25? Y equals 23. Okay. So I have the x value and then the y value. So the answer that we will have here is 48 for my x and then 23 for my y. And again, please don't forget to verify your answer. Okay, so with the same system, if you look at our warm-up, okay, we solved the system using substitution and we were able to get 48, 23. Okay, but look at all the work that we put in here compared to elimination. Okay, so if you notice, elimination, we don't need to do that much work to solve this particular system. With this example, it just so happened that we eliminated our y, but it's okay also to eliminate our x variable. Okay, moving on, let's solve example number 2. In this case, we are going to, if you look at your variables x and y, your y have the same, they have the same coefficient, 3y. So we have 3 here and I have 3 here. So in this particular example, it's easier for us to eliminate our y again. Now, it does not mean that we always have to eliminate y. It just depends on the given system. Okay? If you go back to our steps, okay, if the equations have opposite terms, if we have 4x or negative 4x, for example, then we can eliminate that particular variable. Or if we have the same or identical terms, let's say negative 4x and negative 4x, then we can eliminate that particular variable. Okay? If you look at this example, okay, I have identical terms in terms of my 3y. Okay? If we have identical terms, 3y, then our goal is to use that, okay, and eliminate our y. So how can we eliminate 3y and 3y? Can we eliminate that by adding or by subtracting? Subtracting. So in this case, we are going to subtract the two equations. I did? Sorry. So here we go. So we are going to subtract. So when you subtract, make sure that you subtract each term. So we'll have 6x minus 4x. It will give us 2x. 3y minus 3y will give us 0, and that's what we want. Okay? From the word elimination, we would like to eliminate our variable. Okay? So 3y minus 3y is 0. Now what's 24 minus 18? 6. Then we divide 2 both sides. We'll get x equals to 3. So we already have the x value. Okay. Now we can just use the first or second equation. Which equation do you want me to use? Second one. Okay. Maybe because we have smaller coefficients. So using equation 2, I will have 4x plus 3y equals 18. I will replace x here by 3. So x is equal to 3. Then we will be able to solve our y. 4 times 3 will give us 12 plus 3y equals 18. Solving for y, we have to subtract 12 to both sides. We'll get 3y equals 18 minus 12 is 6. Then divide 3 to both sides. We'll get y equals 2. Okay. So our solution here will be x is 3, y is equal to 2. And then don't forget to check your answer. So I'll have 6x plus 3y is equal to 24. Okay, using my first equation, I will replace x by 3 and then replace y by 2. And then you just have to verify if the left side is equal to your right side. So this is equal to 18. That's 6. 18 plus 6 is indeed equal to 24. So we're able to check our first equation. For the second equation, I'll use 4x plus 3 times y equals 18. So I will replace x by 3. I will replace y by 2. We'll have here 12 plus 6 equals 18. And what's 12 plus 6? It is 18. So the solution will also work for our second equation. Therefore, we are positive that the solution for this system is 3, 2. In this case, we'll have one solution. In our first two examples, it just so happened that it's easier to eliminate our y variable. For the third example, you'll notice that it's easier for us to eliminate our x. Again, if you go back to our step number 2 here, if we have opposite terms, then it's better for us to eliminate that variable. So here, I have opposite terms here. I have the 2x and then the negative 2x. So how are we going to eliminate our x? Add. Very good. So we are going to add the two equations. The purpose for this is for us to eliminate our x. So what's 2x plus negative 2x? That will be 0. We can just cancel this one out. What's 5y plus 3y? That's 8y. And then 19 plus 5 will 24. Give us 24. And then divide 8. We'll get y equals. Okay. Now we can use the first equation or the second equation.
First question.
Yes, okay, I'll use the first equation. Using the first equation, I'll have 2x plus 5y equals 19. But y is equal to 3, so I'll just replace this by y is 3. I'll have here 2x plus 15 equals 19. Subtract 15 both sides. We'll get 19 minus 15 is equal to 4. It's 2x. then divide 2, we'll get x equals 2. So we already have the solution, which is 2 comma 3. And again, don't forget to check your answer. Checking the first equation, we have 2x plus 5y equals 19, but x is equal to 2, y is equal to 3 equals 19. I'll get 4 plus 15. Now what's 4 plus 15? It is equal to 19. So the first equation is correct after plugging in 2 comma 3. Okay, let's check the second equation. I have negative 2x plus 3y equals 5. X here is 2, y is 3. So negative 2 times 2 is negative 4 plus 9 equals 5. We're trying to verify the second equation, so I put question mark here. Negative 4 plus 9 is just equal to 5. So the left side and the right side are the same. So we can say then that 2 comma 3 is indeed the solution for this system. Okay. From our first 3 examples, we observed that after we add or subtract our 2 equations, we were able to eliminate the opposite or same signs. Okay. Now, what if I have a system wherein if we are going to add or subtract, we will not be able to eliminate either the x or the y variable. So if you look at this particular example, 2x plus y equals 8 and 4x plus 3y equals 18. There's no opposite terms and there's no same terms, so we cannot just add or subtract. So if you add this one, x or y will not be eliminated. If you subtract, you cannot also eliminate either x or y. So how are we going to solve this type of system? Okay. What we can do here is to introduce a number. In this case, we are going to multiply one of the equations so that we will produce either opposite terms or like terms. Okay. So if you look at my first equation, I have 2x plus y equals 8, and I have 4x plus 3y equals 18. In this particular example, I decided to eliminate my y. But we can also eliminate our x if we want to. So now let's say we are going to eliminate our y. So if I have 3y here, if I will have 3y on my first equation, then we will produce equations that have the same y terms. Okay? So what I'm going to do here, so that my y will have a 3 as a coefficient, I will multiply the first equation, 2x plus y equals 8, by 3. So I'm going to introduce a number. Again, my plan here is to eliminate my y. And I want my y's to have the same coefficients. Okay? So I want my y here to have a coefficient of 3. I can do that by multiplying my first equation by 3. So multiply this by 3, we'll get 3 times 2x will give us 6x. 3 times y will give us 3y. Now 3 times 8 will give us 24. Now look what happened. After multiplying 3, I have now like terms here, 3y and then 3y. So we'll now be able to eliminate our y. So I can eliminate y here by subtracting. So once we subtract this, we'll get 6x minus 4x will give us 2x. 3y minus 3y is 0, and that was our plan earlier, to eliminate our y. And then 24 minus 18 will give us 6. And here, we can now divide 2 to both sides. We'll get x equals 3. And then, we'll just have to plug this one in to one of the equations. to solve the value of our y. Okay? Now, what if we would like to eliminate our x? Okay, so let me just rewrite this one. I have 2x here plus y equals 8. I have here 4x plus 3y equals 18. If we would like to eliminate x, we want them to have the same coefficient. Okay, so let's say our plan, so we're done with this, okay, eliminating y. What if instead of eliminating our y, we are going to eliminate our x? So we want my x here, the first equation, to have the same coefficient with the x in my second equation. So what should we do with our first equation? Multiply by 4. If you multiply this by 4, you get 8x. I want this to be equal to 4. So we have to multiply first equation by 2. Okay? So if we would like to eliminate our x, then multiply the first equation by 2. So I will have here 4x plus 2y equals 16. I'll just copy my second equation equals 18. And from here, we have now the same, we have like terms for x's. We have 4x and 4x here. I will be able to eliminate my x if I'll subtract my second equation from my first equation. Okay, so what we have here, I'll get 0. I'll have here 5y equals, what's 16 plus 18? That's 34. Is it 34? No, it should be 24. So from here, I can divide 5 both sides. Wait a minute, we're subtracting here. That's why. Let me just do this one again. Okay. So they're subtracting. 4x minus 4x is 0. 2y minus 3y is equal to what? Negative y. 16 minus 18 is equal to negative 2. So when you divide both sides by negative 1, we'll get y equals positive 2. So in this method, we were able to eliminate our x. Okay? Or if you want to eliminate our y, then we can apply this procedure wherein we multiply the first equation by 3. Okay, so let's try to apply this method. Example number 4. Which variable do you think is easier to eliminate, x or y? X, okay? So if you look at your second equation, you have 4x here. In your first equation, you have your x. So if we can make our x's the same coefficients, we'll be able to eliminate our x. So what should I multiply here so that I'll end up getting 4x? So what should I multiply in to my first equation to get a 4x? 4, very good. So I'll multiply this by 4. Okay, you have to multiply both sides actually. So 4 times x will give us 4x. 4 times 3y will give us 12y. And then 4 times 10 will give us 40. Now we are ready to eliminate our x by subtracting. So what's 4x minus 4x? 0. 12y minus 2y. It's 10y. 40 minus 20 is 20. Then divide 10. We'll get y equals 2. Y equals 2. Now we can use either the first equation or the second equation to solve for x. So which equation do you want me to use? Okay, let's use the first equation. It's simpler to use the first equation. So using the first equation, I'll have x plus 3y equals 10, but the y here is equal to 2. So we are going to replace our y variable by 2. So we have here x plus 6 equals 10. And subtract 6 both sides. We'll get x equals 4. So we have the solution 4 comma 2. Okay. Again, don't forget to check your answer. My first equation is x plus 3y equals 10. So replace x by 4, y by 2. And let's try to verify if the left side is equal to the right side. I have here 4 plus 6. And 4 plus 6 is really 10. So the first equation is going to work. Let's check the second equation. My second equation is 4 times x, but my x is 4, plus 2y, my y is 2, equals 20. Okay, let's check if it will be equal to 20. This is 16, that's 4, and then 16 plus 4 will give us 20. Alright, so it worked also in our second equation. So therefore we can guarantee that the solution for that system is 4 comma 2. Okay, let's check the next example. Example number 5. In this particular example, we can eliminate either the x or the y. So you have to identify first which variable you want to eliminate. Okay, you want to eliminate y. So let's say we are going to eliminate our y. So what should I multiply that? So look at my first equation. First equation, I have x plus 2y plus 4. So let's say the plan is to eliminate y. So you want to have our y's to be, you want your y to be, they should have the same coefficient, right? So what should I multiply to my second equation so that I will have 2y here? Okay, we have to multiply by 2. So when we are going to multiply the second equation by 2, we'll get 6x plus 2y. Remember to distribute the 2 and equals 14. And I'll just copy my first equation, which is x plus 2y equals 4. Now we have identical terms already for our y. So since we have identical terms, how do we eliminate our y then? Should we subtract or should we add? Subtract, okay? So I'll subtract this second equation from my first equation. We'll get x minus 6x, which is negative 5x. 2y minus 2y is 0. And we expected that to happen because we plan to eliminate y. What's 4 minus 14? Okay, that's just negative 10. So divide negative 5 to both sides. We'll get x equals 2. Then we can use either the first or the second equation. And we can use this equation or the second equation. So which equation do you think is simpler? The first one, right? The first equation is simpler to solve. So I will use my first equation using the first equation, I will replace x by 2. So I have x plus 2y equals 4. Solving for y, I'll just have to subtract 2 to both sides. We'll get 2y equals 2. Then divide 2, we'll get y equals 1. So solution will be 2 comma 1. And of course, don't forget to check your answer. So when you check your answer, x is 2, my y is equal to 1. So I plug in my solution to my first equation. So 2 plus 2 is actually 4. So my solution will work for the first equation. Let's check my solution. My second equation, I have 3x, but x is 2. Y is 1 equals 7. So I have 3 times 2 here is 6 plus 1 equals 7. We have 7 equals 7. So second equation is also correct. All right, from here we can say that this solution 2 comma 1 is correct. Okay, let's solve example number 6. For example number 6, we have to multiply both equations so that we will arrive at identical terms. But again, the first step here is to identify which variable you want to eliminate. Okay, let's decide as a class. Do you want to eliminate x or do you want to eliminate y? You want x? Okay, let's try to eliminate x. Okay, the plan here is to eliminate x. So I have 3x and I have 4x. We want this to be identical. So what should I multiply to 3x and what should I multiply to 4x so that they will be identical? So what should I multiply to 3x? Okay, and what other number should I use to multiply 4x so that we'll be able to get identical terms? The hint here is that you want to get the LCM of 3 and 4. Okay, go ahead. So in this case, what's the LCM of 3 and 4? It's 12, right? So we want the 3 to become 12 and we want the 4 to become 12. Okay, so to make this 12, I'll multiply by 4. We'll get 12x. What about 4x? How can we make this equal to 12? Multiply by 3, so I'll get 12x here. So that will be our plan. Multiply the first equation by 4 and multiply the second equation by 3. So I will have 12x. What's 4 times negative 4y? It's negative 16y. And then what's 4 times negative 3? That's negative 12. For my second equation, I will have 3 times 4x will be 12x. 3 times 3y will be positive 9y. And then 3 times negative 4 will be equal to negative 12. So look at your x. We have no identical x's. So how are we going to eliminate x from here? Subtract. Very good. So once I subtract this, I'll get 12x minus 12x will be 0. What is negative 16y minus 9y? Negative 25y. Negative 12 minus negative 12, that's just 0. Okay, so let me just rewrite this one over here. I get negative 25y equals 0. Solving for my y, I have to divide both sides by negative 25, which will give me y equals 0. So I have y equals 0. Now we can use either the first equation or the second equation to solve our x. Let's use the second equation, okay? So using the second equation, we have 4x plus 3y equals negative 4. Replace your y by 0. Okay, 4x equals negative 4. So when you divide both sides by 4, what do you have? X equals negative 1. So our solution is negative 1 comma 0. And again, the last step is to verify or check our answer. Okay, so we have 3x minus 4y equals negative 3. Replace our x by negative 1, y by 0. This is equal to negative 3. This is just equal to 0. So the left side is equal to the right side. Equation 1 is correct. Let's check our second equation. I have 4x plus 3y equals negative 4. X is negative 1, y is 0. We'll get here negative 4 equals negative 4. So the second equation is also correct. Okay, so we now know that negative 1 comma 0 is the correct solution for the given